Well, welcome everyone to the ZEB Locate webinar. This should be a fairly brief session, just to introduce the new product that we've launched, ZEB Locate. It's a very simple product, and essentially it'll take data from any survey grade GPS receiver and georeference ZEB horizon. So ZEB Locate essentially works on the same backpack frame that we use for the ZEB Discovery. With a slight change that we have a screw thread on top of the ZEB Locate backpack that you can mount the antenna on. So it's a simple product. It's a ZEB Horizon backpack frame and a GPS antenna. We support any survey grade GPS receiver. We're testing a number of different devices at the moment. So those of you that already have survey grade GPS receivers that you use, we can integrate that data into the system. And we really see this, any application where you need high accuracy georeference point cloud data. ZEB Locate is designed for that. I'm sure many of you are familiar with the SLAM technology that we have. Gives you excellent point clouds, but only in a local coordinate system. ZEB Locate enables you to automatically georeference that data. And again, we see this for lots of different applications, infrastructure mapping, stockpiles on mines where you want to get that good repeatability, be different sets of measurements, monitoring applications. So a whole raft of different applications. I've already talked through the hardware a little bit, but I'll just talk you through what we've got on the screen here. This image of the ZEB Locate backpack. We've been testing the Trimble Catalyst GNSS receiver, which I'm sure some of you are familiar with. It's a subscription-based GPS receiver. It works with the same clip and go technology that ZEB Horizon works with on the backpack frame, so you can take the scanner on and off easily. And again, as I've already discussed, we'll support any number of survey grade GPS receivers, and we're testing some different systems at the moment. But anything that gives you that kind of high accuracy data, we can use with ZEB Locate. And I think the important thing, those of you that are familiar with working with GPS systems and mobile mapping systems, you'll appreciate that often the most challenging part of any system is synchronizing all the devices. So typically cameras, laser scanners, GPS receivers, IMUs. We're using a purely software-based approach. So we can take any GPS data stream, automatically merge that with the data that comes out of the ZEB Horizon and georeference the data. So there are no hardware changes required to the ZEB Horizon, which is important. We're not using a PPS trigger or any other synchronization method other than using software, which means that the ZEB Locate will also work with any ZEB Horizon scanner. So any of you that already own ZEB scanners, you can use ZEB Horizon and ZEB Locate together, and we'll be able to automatically georeference that data. So that's a really important point to make. And how it works, it's very simple. Capture data in the field. So you need to capture SLAM data and GPS data at the same time. Copy that data to your computer, process the SLAM data in GeoSLAM hub. That will give you your point cloud and trajectory file. And I think there's an important point to make here that the ZEB Locate software is not integrated into GeoSLAM hub. It's shipped as a separate software application. So once you've processed your SLAM data in hub, you get the trajectory and point cloud data. We then take that data into ZEB Locate software. And that's where we merge the GPS data and the SLAM data automatically, and that will give us a georeferenced point cloud. So point clouds at the moment are coming out in UTM coordinate systems. We will add support for additional coordinate systems in the future, but at the moment, UTM coordinates. And really, in terms of typical accuracies, with the Trimble Catalyst, we're looking at accuracies against a control network that we've tested of 20 to 70 millimeters in X, Y, and Z. So very accurate results, particularly given that we're using a software-based approach, which is super flexible. So again, we're really happy with the results we're getting from the system. We are testing different GPS receivers as well, so we'll have more information on different receivers in the not too distant future. And I think the other important point about ZEB Locate, and this is something we've been asked a few times, you can also go indoors and outdoors on the same data capture. Because we're using a software-based approach, we can essentially ignore the GPS data that we capture indoors, throw those out. We have an accuracy filter in the GPS data, and those of you that are familiar with GPS know that there are a number of parameters you can use to throw out poor GPS results, so P dot, G dot, positional accuracy. So we support those in the software, so we can throw out the data that isn't good GPS and only use the good GPS data to georeference the data itself. So it means you've got a lot more flexibility in how you use your system. The public launch, this is essentially an introduction to the system now. Documents and supporting materials will be on the GeoSLAM webpage shortly. And really, this is my last slide. I said it'd be a fairly brief session. The ZEB Horizon gives us that real flexibility on how, supporting a different range of accessories, and ZEB Locate is the latest one in that range. Super flexible. We support any GPS receiver. We're getting survey grade results, which we're really happy with. And again, as I said, it's a separate software application that runs alongside Hub at the moment. So really, that's a super brief introduction to ZEB Locate. It's a simple application, so there aren't an awful lot of things I can tell you beyond. It will merge GPS data with SLAM data and give you a georeference point cloud. So does anybody have any questions? If you can put questions in the chat field, I can answer them while I'm online. So I can see the first question here. What is the input file for the GPS trajectory? At the moment, the files that we're using are latitude, longitude, altitude, and an accuracy value. At the moment, we're using positional accuracy in X, Y, and Z, but that can be also PDOP as well. So the trajectory standard format at the moment is latitude, longitude, altitude, and X, Y, Z. I'm just trying to get more questions up. How good is the accuracy of the georeference cloud with the GPS? So we've tested that against the control network, and we're seeing typical accuracies, as I said in the presentation, of 20 to 70 millimeters. That's obviously going to depend, as you all know, those of you that work with GPS, on GPS conditions. So that will vary. But in open sky conditions that we've been testing it in, we're looking at between 20 to 70 millimeters, and that's using the Trimble Catalyst receiver. So we do expect to see different, potentially better results with different receivers as well. Right, I think that's answered all the questions I can see in the list. I can see another question here. Do we need additional software to process GPS data? That's going to depend on the type of GPS receiver that you use. We've done our testing with the Trimble Catalyst receiver, which doesn't require additional post-processing. That receives corrections essentially over the kind of 4G network for the phone. Depending on the type of receiver that you use, some of those will require post-processing, others not. So that's dependent on the type of receiver you use. But as I said, we support a wide range of survey grade GPS receivers. So if post-processing is going to be a challenge for you, then there are systems that will post-process or give you positional data in real time. I can see another question here from Carlos. Can we integrate Discovery with Locate? We haven't done that yet. I think it's more for us, kind of usability is the biggest challenge for us there. I think using multiple devices will get much more complicated. But in principle, yes. We're also investigating the accuracy that we get from the GPS receiver that's inbuilt into the NC-TEC camera. So there is only an L1 receiver, but we're working on accuracy determination of that at the moment. So in principle, yes, you can. It's not something that we recommend. But again, if you've got your own GPS receiver and you want to manage that data independently, that's fine. We can synchronize that data. I can see another question here. Can we buy GPS receiver from GeoSLAM? We typically would recommend that people supply their own GPS receiver. We can recommend a number of suppliers, but we think we'll have better flexibility if people choose their own GPS receiver. I can see another question here. Is the Locate software going to be integrated into GeoSLAM Hub? Not at the moment. That's not currently our plan. I think we want to keep it as a separate application for now. It's much easier for us to develop a more flexible solution outside of Hub at the moment, which means we can easily support many more GPS receivers, and we think it makes a kind of a sensible add-on to the kind of flexible architecture that we're trying to build at the moment. So at the moment, we don't have an immediate plan to put Locate software into Hub. I can see another question here. Does a Locate software output also new trajectory or only point cloud? It will also output a georeference trajectory as well in UTM coordinates. So it will be point cloud and georeference trajectory. And I can see another question here. Will license be tied to Hub's license? No, we're going to license this application separately. So it will be an additional license that you need to run the software. Okay, it looks like there are no more questions coming in. So hopefully that's given you a good insight into the ZEB Locate solution. We're just running final tests on the software now, so that will be available very shortly. And thank you all for listening. Any questions, please contact me at GeoSLAM, neil.slatcher@geoslam.com, and hopefully I will hear from you soon. Thank you very much.